My name is David. I am one of the founders of the Arduino Platform. I have to say I'm really, really honored to get this prize. To me, it's a recognition to many years of work. The platform was created 10 years ago, but it's based on a lot of work made before that. I'm also an assistant professor or adjunct at Malmö University, which sounds a lot better in English than in Swedish, which is Malmö Högskola, which is not really university, as you know. But we will make it there. There will be enough PhDs very soon. And I'm one of the researchers in the Internet of Things and People research group. So that's a bit about myself, as well as I really like to write about very obscure subjects, like how to build physical accessories for Android devices or how to program wearable Android devices. I'm an educated microelectronics engineer, and I worked before as a project manager at a radio company in Spain, as well as a microelectronics engineer at Infineon Semiconductors in Germany, before I moved to Sweden to teach at an art school. So you get a picture of the person you have in front. Well, the thing is, I teach artists and designers how to use electronics in their everyday practice. And the reason for this is that more and more of our lives are becoming digitized. More and more of the things we do are basically based on digital electronics. And I noticed a tendency around 2002 that there was more and more of a disconnect between what designers were trying to do and what was inside the objects. And at the time I was teaching design students how to program Java. You can imagine how challenging that can actually be sometimes. So I thought, what if these people that will become the industrial designers of the future had to understand how devices will behave in the future? So I came with to the idea of like, we need to teach them how to build state machines. We need to teach them how to make things that can react to certain stimuli. They need to learn about sensor technology. They need to learn about actuators, about motors, and so on. Of course, not how to make a motor, but just how a motor could be used in practice. So I came with the idea of making something like this, which was a circuit board that my design students would put together by themselves. It would take them about 12 hours because most of them had never soldered in their lives. And the question is, what could they achieve with something like this? This was 2003. So some of the first projects my students did were an automatic confession booth. As a Catholic, I'm perfectly allowed to show you this. If you analyze the act of confessing, it's a very, very repetitive process. Basically, people have to enter into a place, they have to lock the door, they have to kneel down, they have to say a bunch of stuff that nobody really is going to listen to, and then they're going to get punished in a way, and they will just leave. So we could just simulate everything with a very simple state machine that was just playing different sound loops, inviting people to close the door, kneel down, confess their sins, and after 3 minutes would tell them, okay, your time is over, it's better if you leave. And we made it so well that people really believed that there was somebody hidden in this box. And you can see this is a very, very small cabin. It's like, barely the person could fit kneeling down. Some other machines that we built was, for example, a machine to allow you socializing when you go out drinking. Again, you have to put this in context. This is design students trying to learn about digital technology, so I try to give them pretty broad design tasks. In this case, my students came with the idea that when you go out and socialize in Sweden, you don't really start talking until you have been drinking enough. So they thought, okay, this could be extended. There are some people you only want to meet when you've been drinking enough. So they had the idea of hacking the telephone contact list in your Sony Ericsson T610, which is one of the most sold phones ever by Ericsson, so that you could only access some people when you had been drinking enough. So we built a breathalyzer that was hooked into this phone, so when you had enough alcohol in blood, it will let you access those people. And the more alcohol you had in your blood, as the level was rising, the list was decreasing slowly because you didn't want to call your ex-wife. And after a while, you could only call a taxi of your own trust because you might make a mess in the taxi. Well, we tried to sell this to Sony Ericsson because Sony Ericsson's design offices were just 20 minutes away from our office at the university with absolutely no success. But things like this led us to understand that there was a need to build a prototyping platform that people with absolutely no knowledge in technology could start using in just 5 minutes. The idea was you should go from zero to hero in no time. You should be able of building things and learning how digital technology works by spending as little money as possible. And this is actually the success of the Arduino platform. This is an open source project that started exactly 10 years ago in a basement in Italy. And since then, we built a community of believers. So we build a community of people that like to learn about technology in a bit of a different way. And it ranges from 5 years to 99 years of age. And they come from all over the world. This is a graph that shows the different continents and where the audience arriving to our website is coming from. Yellow represents Europe, green represents North America, and the other colors represent the other continents. I computed these graphs plus some others because for 6 years in the project, I was basically running the web services. I became a father, and more or less like you, we're sitting home, and I was running the website for the project. This is one of the advantages of running an open source project. You can do it from everywhere. So this was the first board we designed. And in 2005, there were still computers having a serial port. So we came with the idea, we need to build a system that can be as inexpensive as possible so anybody could use it to start working with electronics. And this design, if you look at it carefully, you will realize that, for example, all the resistors that have the same value are grouped together. So I put together the circuit board, this is actually my design, to make sure that people that didn't know how to solder wouldn't make mistakes while they were building their boards. It was probably not the most correct thing electrically speaking, but it was definitely the most correct thing from an educational standpoint. But very soon we realized that we were running out of computers with serial ports. Actually, most of our students at design and art schools, they work with Macintosh computers that never had a serial port. So we jumped into designing a board with a USB port. And when we added that surface-mounted component up there, which is basically a USB to serial converter, we understood that it was going to be a hell of a problem to let our students solder the boards, because if they had never soldered before, soldering a surface-mounted component was a bit challenging. So we asked a manufacturer how much it would cost to put on a pick-and-place machine and mount that piece for us. And he said, turning the pick-and-place machine on is so expensive that I can put all the passive components and actually give those to you for free, if you want to add that chip with the machine. And I said, okay, let's do it like that. And then we ended up selling 1.5 million of this, which is a completely fully mounted prototyping platform that cost only 250 Swedish crowns. And this was the key aspect. The key aspect was we made something where the price was so low that it didn't matter for somebody I didn't know to take the risk to buy it, to get started trying with technology. That was the key. Well, since then, there have been literally hundreds of boards. This is just small teaser from my personal collection of circuit boards. I think I have over 250 boards myself. And there is boards made by us, there is boards made by other people, there is clones, there is derivative designs, there is boards that can address a lot more pins at our boards that run on 32-bit cores, boards that run on 8-bit cores, etc., etc., etc. So there's really a huge amount of boards in the world. And the way we build these boards is by actually asking the community. We are strongly engaged in a conversation with the users that want to use these things. So we apply open source software techniques to open source hardware techniques. As a matter of fact, we were some of the builders of the open source hardware licenses, because until the moment we started, there were no proper open source hardware projects that were facing any challenges, like trying to address thousands or tens of thousands or even millions of people with open source hardware designs. But in the end, what we try to do is actually not to design hardware, and this is a huge misunderstanding. People look at Arduino and they think this company is only making hardware circuit boards, basically. But what we do is try to achieve very complex design scenarios where you want to integrate a lot of parts, like you want to add sensors to a mobile phone. This is, for example, an experiment that I designed for the people at SIX, the Swedish Institute for Computer Science, to prototype using mobile phones and hardware parts. So I basically built this whole thing for them to try out how to write code on phones and control the physical world and vice versa. But the things that you can apply this to a lot of other things. At some point, Sony came to our studio in Malmo and they asked whether we could actually make their watches run on Arduino software. And so we did. We basically had their watches. It took us about 48 hours. And then we allow people running their own software on these smartwatches. Just because they had the right architecture, we could just port all of our know-how very quickly to a completely different hardware platform. And what happened is that we published our results on the internet, and barely 24 hours later, somebody published the first open source game for the Sony smartwatch. I don't know if there is sound in the room. Yeah, there you go. The sound doesn't come from the watch doesn't have any speaker, okay? It's just adds a lot to the experience. The funniest part is that we couldn't publish at that moment that we had hacked the watch, just to avoid the kind of legal situation. So we didn't publish it under our name. The guy that made this software happens to be a friend of mine, but he didn't know it was me that made the software. There is other things. This is the first project ever made with an Arduino board. It was made in 2005, and here my students were trying to hack into the human body. So they built a machine that was giving a dancer electroshocks in elbows and knees, depending on the music. You know, designers, right? And there you go. Back then we had very bad cameras. You can't really hear the music, but you imagine like a techno rave kind of song. Boom, 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 boom. And he goes boom, boom. Depending on how the music is equalized, the guy gets electroshocks in different parts of his body. I mean, this project was made before, okay? Like there is artists like Stellark that have been doing this since the 80s. The difference is that this is a second-year design student that had no experience in electronics until 4 weeks before making this project. This is the big difference. Okay? So people here with absolutely no experience, they could start building things in no time. I want to show you one of the company projects we did. This is a Chevrolet Captiva. It took us 5 days to transform it into a Google car. There you go. It drives by itself. In this case, it's one of the tests we did with a remote control. In the end, we added some artificial intelligence, and it was listening to the music and driving around. The hard part is that we never asked for police permission in Malmo. So, yeah. Well, this is thanks to the fact that there is a lot of technology right now easily accessible, and we are contributing to build these communities of people that share their knowledge in an easy way, making it easier to build things like this. Here, the robot actually controls the pedals, even the on and off key in the car, and so on. Later, when we turn off the cameras, I will show you the final result that I can't show, because in the end, Chevrolet thought it was too risky, so this video that we did for them never came to life. And some other pretty impressive things. This is a light installation that we did in Jakarta in Indonesia. We did this for Nike. I will lower a bit the volume. And what we did here was that We built a light installation that is 100 meters long, 5 meters wide, and it was meant to be the last 100 meters of a marathon happening in Indonesia. So Nike commissioned this piece, and it's an interactive light game. As you run underneath the lamps, the light follows you. It took us about 16 days to put it together, mostly because of the monsoon period that nobody told us about. So it was raining 12 hours a day. The amazing thing is that our electronics had no boxes, and they ran even though they were wet all the time. So that's a feature, so we never thought about it. So this is the way it functions. It follows people going underneath the lights, and it also has the run against the world champion 100 meters kind of thing. So the lights, they light up in 9 seconds 58, and you have to run against it. You will obviously never make it to the end before the light makes it, but you can try. You know, the best part, I always tell this part of the story, is that in the end the marathon happened during daylight. So you could never see the lamps. But okay, they paid us anyway. So these are some of the things people are doing with Arduino. I just show you the things we do that are pretty large scale kind of things, but people solve very typical engineering problems. This is the inverse pendulum, and this is not exactly the video that I would like to show. There is another video where a 16-year-old kid managed to solve the math for the inverse pendulum and connect it to a Wii remote. So he made what everybody else couldn't solve just because he had enough time. And here you see a very simple experiment of an inverse pendulum. So he switches it on, and there you go. And of course, inverse pendulum is the scientific base for the Segway kind of vehicles. And of course, people are building a lot of vehicles based on Arduino. So there you have a self-built Arduino controlled Segway. Everything you need is 2 power drills, a big battery, an Arduino board, and that's it. But again, the thing is that kids at a very early age can do this. These images I want to show you now are part of a program that I coordinate that we're actually doing in 3 countries, being Ecuador, Spain, and Sweden. We're doing this in this corner region right now. And we basically teach, during 6 months, teachers how to run their class using digital technology, using basic electronics, mechanics, and so on. So this is one of the experiments made by some of the kids, basically measuring pulse and some other things from their body. They also make music instruments. They make laser harps, or scarecrows, or greenhouses, or robotic arms. This actually is a very nice project. It was made by 2 11-year-old kids. So basically, through imitating things that they find, they can achieve quite a lot by themselves with very little help from their teachers. We see a lot of projects like this one, where school in Spain that had like absolutely no resources, they had about 3,000 crowns a year for budget in their lab. They build very simple robots where every single part is recycled. And I always like to show and highlight this part here that you may see every morning really close to your armpit. These robots, they cost about 15 euros to build in total. But inspiring that, I spend a lot of my time going to places like Mexico City, where I've been teaching at one of the poorest neighborhoods in the world that is called Iztapalapa. It's a neighborhood that has 3 million inhabitants. And there is one art center where they run workshops for kids and people in general for about 6,000 people a week. And I was teaching electronics to completely random kids coming for about 3 years. I spent 2 weeks every 2 months in Mexico. No surprise, my wife is Mexican, by the way. And at some point, I asked the kids, what do you want to do next? And the kids told me, we want to build a robot. And personally, I am against robots. I mean, I'm not against the concept of having robots, but I think that in electronics there is so much more than robots. There is communications, there is wearable computing, there's things that you can attach to your body. But kids, robots are a really powerful instrument to teach kids technology. So I was forced to design a robot, and since every single part in the Arduino ecosystem is open source, I reinvented the board so we could manufacture it in Mexico. The only thing I had to find was those wheels. And I just went to a toy store and found some wheels. So I could build a robot entirely with parts I could find in the markets in Mexico, so that they would cost only 40 euros and the kids could bring it home. Then the kids would do whatever they wanted. Like, for example, this. It's a really funny character in Latin America. It's called Eggy. It's, of course, an egg that smokes marijuana. And he gets red eyes. So this was made by 14-year-old kids. I don't know if you're familiar with 3D printing. I guess you are. But 90% of the open source 3D printers I built with an Arduino board. So this is one of the examples of one of the printers we make every year at our office in Malmo. We usually run one workshop, and we only make 15 printers, and we make a new design every year as a dissemination activity. This is our second model that is made in stainless steel, so it's heavy as hell. But it's very good, it's very sturdy. But the thing is that once you have printers, you can do other things like robots. This is a really famous 3D printed design. It's called the Skybot, and it's one of the most minimal robots you can build. You just need a bit of intelligence, 2 servo motors, a battery, and an ultrasound sensor. And you can build this in no time. And it takes probably like half an hour to print, and once you have that, everything else is a given. Well, actually, the wheels are also printed, by the way. But the thing is that as I started to talk about robotics with people, I was approached by these 2 kids. Ivan, that is now like this much taller than me, and Nerea, that's an intern at Arduino in Malmo. And at the time, they were already 3 times world champions in robotic soccer, and they were from Spain. So they approached me, hey, we're from Spain. That was the catch, right? And we are 3 times robotics champions in football, and we would really like to build a robot with you. And the thing is that these kids, at the age of 14 and 15, they were true engineers. They were spending like 3,000 or 4,000 euros and 8 months of their lives in building a robot from scratch that would go compete against robots from other kids and win. Again, I don't know how many of you will spend 3,000 euros in building a robot, but I know that the average human being will not do that. And as I told you in the beginning, one of the goals in Arduino is to make this available at a cost-efficient way to people. So if we want people to start with robotics, the robot couldn't cost 3,000 euros. So we spent 2 years designing this, and this is a robot that costs only 200 euros, and that can give you a lot of instructions because it actually has a screen on it. So you can play with it, but then you can also build your own experiences with it. And the whole idea is that in order to build a robotics platform, you just need to open the package, and in 5 minutes, you're ready to go. So here is like the unboxing experience of the robot. It's a 3 years younger David that you can see in the picture. But that is my kitchen for real, by the way. I have a rainbow. And the only thing you need to do with the robot once you mount it is actually charging the batteries, because they might not come charged from the factory, so you just wait a little bit, have a cup of coffee, and a couple of minutes later, you can start coding your robot and doing the classic experiments like following a line or just moving straight or rotating or whatever. So it was quite an experience to design this because, as I told you, I designed this with 2 people. One being, when we started, Nerea was 16 and Ivan was 15. They had already grown 1 year. And it took us 2 years because I had to take all this knowledge they had and just condense it and go back and forth and deal with the fact that these kids were going to school. So they had to go to their exams. So we had to stop development for several months before we could continue because they had no time, and so on. The only problem is that this robot was too expensive because it ended up costing 200 euros and still too much money. So we moved into making a robot like this one that is only 50 euros. This is our next design. And today I got the sad news that Vinova didn't give us the grant to go farther with this project. So I will have to figure out a different way to pursue it. Anyway, so the idea is that we build this robot, and again, kids will do with it whatever they want to. So we built a robot and we made 150 of these, and we went out and tried it out with 150 kids, and we gave the robot to them. So we built a small community of kids in a city in Spain that are right now going around, playing with these robots, building their own things, and make it look like they want. By the way, in Spain there is no Eggy, there is Garfield. And there is a lot of different spiders and monsters that can grab stuff and move it around. But I have to say, some of the main goals behind Arduino are actually bringing programming the physical world to people. As I told you, robotics is not the only thing. I mean, we are more and more seeing how more and more devices in our world contain digital technology. And in my class, I always say to my students, your microwave has a microcontroller, your elevator has a microcontroller, your car has more than 70 microcontrollers. And that's an eye-opener for people. When you tell them things like this, they understand, okay, maybe I need to get some better understanding on how things work. So we try to analyze different ways of programming the world. And I don't know if you're familiar with block languages. This is a visual programming language based on Scratch that's designed at MIT. And we try to figure out how to bring programming languages that are used for screen experiences into programming microcontrollers, programming embedded microcontrollers. And we believe that this is not really the right approach, because in the end, there is no difference between doing this and writing code. If you look at it carefully, you can translate this program directly into two functions, one that is called setup and one that is called loop. And each one of the events, each one of the sequences in the code are clearly stated. So there is no difference between this and typing in the code. So why do we need the language like this? In my opinion, it's useless. Because what happens is that people in their brains, what they understand is events. When you ask a 5-year-old kid, what do you want this computer to do? He tells you, when the temperature goes like this, I want this to turn the fan on. So it's event-based, it's not sequentially based. But we program things sequentially. We program everything by a pooling mechanism. So we try to figure out how to create embedded programming languages that are event-based instead, and that have no single word written on them. So it's one of our challenges in Arduino right now. Because what we want to achieve is people reprogramming the world in a graphical way with state-of-the-art of technology. So we also want to move away from this idea that schools, for example, need to have the oldest computer running the oldest version of Linux or Windows 98, like it's the case, so that they can actually go and program something. Then they will never make anything meaningful. Of course, they can try, but... So I want to show you one of the collaborations we make in Arduino right now, where we collaborate with a company called Top from Malmo. It's a design studio that does a lot of the user interface design for Samsung. And they are looking into a programming language that looks like this, where they try to program interactions between phones, tablets, computers, and together with us, the physical world. And Michael here just created a way to make the phone talk to our robot in a very simple way. And that's the program that makes the phone talk to the robot. It is this simple, of course. It's just connecting data flows between parts. If you're familiar with LabVIEW, it's actually kind of similar. It's just that it's open source. That's really the big difference. And I want to close my presentation talking about one of our research projects in Arduino. Even though we started as a very small company, we are right now a 70-man operation, I think, with offices in 6 countries. Malmo is the second biggest office with 20 people right now. And we are running a European project called Pillars, where I'm head researcher. And in this project, we are trying to create new tools for learning. It's called learning analytics. So the idea is that the system will be smart enough to tell you, I think you're going to make a mistake. So that's the whole goal. So in order to do that, we had to create a system that would allow you to plug sensors to a computer and let the computer understand that you're plugging something that might or might not work. So I'm going to show you a video that I might have to ask you later to pixelate in the movie. That is explaining which is our next frontier in Arduino. And yes, it has a Swedish name. So the idea is that systems are automatically recognized in the computer, so you can start programming them by just dragging blocks around and connecting pipes between the outputs from pins to the inputs from other pins. So in the last, I don't know how many minutes, I gave you an introduction for the last 10 years of my work, from the moment we started making a circuit board in a basement in Italy to today. Thank you very much. That's me.